MPLS Traffic Engineering RSVP. In this video, I'm going to talk about the resource reservation protocol and its usage on the MPLS traffic engineering. You know that in this course, in the videos that you saw in this video series, we talked about the RSVP and also we configured RSVP and we know about the function of the RSVP. But in this video, we want to talk exactly or with a dedicated scenario to RSVP. Here, our goal is to understanding the RSVP's function with more detail and also how RSVP can help the MPLS traffic engineering. Also, for example, we will learn about the RSVP message and some other detailed information about the RSVP with the extension of the TE. In this video, I'm not going to talk about, for example, a new command or a new, for example, configuration part of the traffic engineering. Here we are talking about the knowledge about the RSVP or resource reservation protocol. Let me first reviewing some of the topics about the RSVP, but before then let me to emphasize that we learned about the RSVP or some topics of this video in the previous videos, but here we are reviewing the concepts of the RSVP and also we will learn new topics, new things about the RSVP. The first question is that what is the origin of the RSVP? Let me to say that the origin of the RSVP is in the quality of service. Here, let me to write quality of service. You know that we have some techniques for giving qualities to some special traffic. The techniques that we use for giving quality to the special service such as the voice or video traffic is calling the quality of service. Okay, quality of service can be implemented with one of these three methods. The first is the best effort. Best effort means we don't have quality of service. Okay, this is the no QoS, for example, form, and then another method of the implementing quality of service is integrated service. Okay, integrated service or intserv. The other name of this service is intserv. Okay, and after that we have another method for implementing the quality of service, the diffserv or differentiated service. Okay, or diffserv. Another name of this type of quality of service is diffserv. Okay, today's we are using the diffserv model for implementing the quality of the service, this method differentiated service or diffserv. But in the old days we use the intserv method. Okay, intserv method is a method that we can reserve the quality, for example, bandwidth for some type of traffic. Let me to talk about a little about these methods, but don't forget that quality of service topic is beyond the scope of this course. If you want, you can watch my quality of service video to learning about the techniques of the quality of service. But let me to talk about QoS briefly in this video for better understanding the RSVP. Okay, first starting with the best effort. In best effort model of implementing quality of service, we don't have quality of service. This means that when you have a network without any techniques of the quality of service, we are using the best effort model, and this means that all of the devices should use their best effort to giving quality to the traffics, but we don't implement any technique of the quality of service. And the next method or the next implementation method of the quality of service is intserv model. This is the old model in implementing quality of service, and today's we don't use the intserv model. Intserv, okay, is working with the RSVP protocol. RSVP is the abbreviation of the resource reservation, okay, protocol. What is the function of the RSVP or resource reservation protocol? Let me to talk about this protocol, but I'm not going to for example talk about the detail of the RSVP. I'm going only to talk about the RSVP briefly. Okay, RSVP's function is reserving the pass. Let me talk about that. Look at here. Assume that in the old days we had one PC1 connected to the router 1 connected to router 2, and then router 2 connected to router 3, and after that to router 4, and for example PC2. Okay, and PC1 and PC2, okay, need to have communication between each other because the PC1 has one application that needs to communicate with the application of the PC2. This application has some requirement. For example, we need a minimum for example 1 megabit per second of bandwidth for communication between these two applications. Okay, because of that, because we need to ensure that we have this amount of bandwidth between the PC1 and PC2, we need to enable RSVP protocol on the PC1 and also on the R1 and also on the R2. Okay, this is the technique of quality of service. Another router is R3, and then R4, and finally PC2. Don't worry about the detail here. We don't want to talk about the detail of RSVP. We are reviewing the RSVP briefly. Okay, we need to enable RSVP from the for example PC1 to PC2. Then in RSVP, with RSVP, we can reserve the requirement that we need. For example, PC1 from the application can send the RSVP pass message. RSVP has two important message: RSVP pass for request and RSVP reserve for a reply. Okay, I will talk about them, but we need to send the RSVP pass message to R1 with the requirement of we need, for example, bandwidth of the 1 megabit per second. Okay, then R1, okay, should advertise the RSVP pass to the next router, because with some mechanism we can say to R1 that this pass goes to which IP address. Don't worry about the detail. And after that, let me to say that when R1 receiving the RSVP pass message in this interface, it should reserve, or it should stand by the 1 megabit per second of bandwidth on this interface, for example. This means that R1 doesn't allocate the bandwidth, but it should stand by that amount of bandwidth. If other routers can reserve the amount of bandwidth, the R1 also should reserve the bandwidth. Because of that, now R1 on this interface, okay, should allocate the bandwidth of the 1 megabit per second, and it should stand by this bandwidth but not reserve it. Okay, then it can forward the RSVP pass message to the router 2. Again, in router 2 we need to stand by the bandwidth of 1 megabit per second on this interface if the router 2 or for example has this amount of bandwidth. And also then again the R2 should forward the RSVP pass message to the next router, in the router 3. Again, in router 3 we have the same condition. The router 3 can stand by 1 megabit per second of bandwidth. Okay, and after that again the RSVP pass message should be forwarded to the router 4. In router 4 we have the same condition, for example bandwidth 1 megabit per second. And finally, when we have this amount of bandwidth to the router 4 can send the RSVP, okay, or in some cases PC2 can send the RSVP, for example reserved message, RESV. In this RESV we can say that we reserve the bandwidth of the 1 megabit per second for this traffic. Okay, when the RSVP reserved message is receiving in router 3, the router 3, okay, can reserve the bandwidth of 1 megabit per second, and also send another RSVP reserve message to the router 2. Now router 2, understand that the router 3 reserved the bandwidth of 1 megabit per second. Because of that, it can create another reserve message, RSVP reserve message, and forward to the router 1. It means that I reserve the bandwidth of 1 megabit per second. You also, if you want, you can reserve this amount of bandwidth. And finally, the R1 can send the reserve message to the PC1 for the bandwidth of the